Hello students, welcome to the session of remote sensing and GIS. So we are going to discuss about the shape of earth. What is the shape of earth, right? Why we need to see that? We have already discussed about the GIS components, the functions, tasks, mechanisms, chief work, which are the data which are incorporated and built with the help of GIS, that is vector data and the raster data. And now we are going to see that what is the shape of earth, why we are using this technology, and how much accurate is this technology is the major question. When I say that the local governing body can use this, when I say that in the country India, any scientific planning for in the field of civil engineering for smart city, for mega city, metro city, everything can be done with this technology. So what is the main and how we can validate this? Now, before going further, I would like to give you here the thing that is known as the vector data and the raster data. You are very much aware of this. We have already discussed what is vector data and what is raster data. You have seen this also, that line. When I talk a line data, you can see the GIS vector format and the raster format. Numbers of cells and grids are basically showing the raster, right? And the points, numbers of series of points, that is geographic coordinate, shows the vector. Similarly, for the polygon, you can see the vector and raster format, right? I guess with this all, you are very much clear what is vector and what is raster, right? Now, you know all that before few years ago or almost before a decade, we have started making the modern maps. Why we are making it? What is the importance of making it? With the help of map, we can analyze that where and for which point or for which location I want to do the analysis. What is more, what is less, which is which continent is famous for which. Every information can be predicted with this main geographic location, that is a map, right? Map is basically a visual interpretation. What you can see in the photograph, you can analyze, right? You can see here the satellite image, what I have shown below. See the number of houses you can see. This is the satellite view. From the top, you can see with the help of satellite that how it looks. And then we do the numbers of analysis. So this is modern maps. Now, before going further, I have a major question, that universe is a subset of space or space is a subset of universe. These two are the major question. What is universe? What is space? It can be defined as everything that exists is universe. Everything that has existed and everything that will exist is universe. Then what is space? Universe consists of space, time, and form of energy. So, space is basically an empty space area between two things. That is what is space. And every that space has a location. When I talk about spatial data, yes. So now it is, yes, scientifically a major question that universe is a subset of space or space is a subset of universe. I am not talking here the space means the aerial photography or the space technology what we see that with the help of satellite. Here I talk about the space surrounding you, area, space, distance. This is what is space considered it. Universe, I have very well in a simple language explained what is universe. Now let us see that what is space, what is universe, what is a subset. The answer is both are the subset of each other. Universe consists all the things which are in space, right? And even if you see the technical sense, space also has all the things which is there in the universe. So we cannot bifurcate both the things. Now the major question comes here, the shape of Earth. I have said the shape of Earth is spheroid, circular, round, ellipsoid, and here you can see the original shape of Earth. Can you see the moving shape of Earth? The Earth is rotating, moving. That is called as geoid. It is also spheroid. It is also geoid. Technically, the shape of Earth is geoid. Now you can see whenever or in the whole life till now we have seen the circular shape of Earth only. You have never seen the shape what is shown here in the presentation, that how is the shape. This is spheroid, this is geoid, right? Now what I have done, let me go back, and you have seen this maps, right? Can you see these maps? How these maps are prepared? Globe. Everybody are famous with the globes, and you can see the first two maps are from the globes only. Circular globes, and you can see here it is flattened. Right? Now, let me tell you that what is the importance of it. When I say that Earth is geoid or spheroid, I have divided the whole Earth into the horizontal and vertical lines. Can you see here in the figure I have shown that latitudes are the horizontal line, which is from the 0 degree, 30 degree, 60 degree, 90 degree. It changes the equator. From the equator, two equal portions are divided into numbers of horizontal lines. And similarly, the meridian which is joining from north to south, and you can see 30, 60, 90. This is how it is divided into the vertical portion. So this earth is of geoid shape. We the human being have considered it as a circular round, and then we have divided the whole earth into the horizontal and vertical lines. That is what I have shown here. From north to south, that is your meridian. From east to west, that is in the center portion of whole earth, that is your equator. How many lines are passing from equator? How many lines are passing from north to south? That is meridian. And we have derived our earth's grid. Can you see this green? What I have shown here? When you add latitudes and longitudes, and you get one grid on the earth. Now students, mathematically we have divided the earth, and you can see here how it is divided. Can you see? Yes. This is how the calculation for the earth grid is done. And now we are able to do all the measurement on the Google Earth or in the Google Maps application or whatever application you use for the measurement. But the primary source is such that we have divided the whole earth into the latitudes and longitudes, and then we are working on it. So after doing this only, we have derived with the coordinate systems. What is coordinate system and its importance? Why? Because this is the coordinate system we are going to see in detail also. But let me tell you why we are doing that coordinate system concept. What is the importance of it? Basically, Earth is divided into latitudes and longitudes, and we have got the Earth's grid. Now it is a geoid or the spherical shape. I want to do it a flat. When I open this earth into the flat surface, what happens? measurements changes. There is a change with the shape, right? So I need to take that consideration, and that is why there is a derivation of coordinate system. You all know latitudes and longitudes are in degree, minute, second, right? Because it is circular. Earth is rotating, it is circular, so it is having degree, minute, and second, right? But when I open it, it will show me into the meter, area, yard, inch, whatever you want, you can have that unit, right? So this is the concept why latitudes and longitudes important. And now can you correlate that why we are making this map and how these maps are made, how these data are made? See the points, you can see the points, geographic coordinate, this word is used. These geographic coordinates are basically derived from these things what I have seen and made you here understand that this is the latitudes and longitudes, and we have the earth grid, and now we are making it flat and we can make the maps, we can have the vector data. And this is why all the data which you are taking from Google Earth, that is what I have taught in the previous session, that point, line and polygon, that is why this is accurate, because we are dealing with the latitudes and longitudes. This is the major reason why it requires the latitudes and longitudes. So, this is how it deals with the technological era, that GIS is very helpful in our day to day life when we want to do any analysis which is related to the earth surface. And you all know that whatever analysis, if I want to measure an area, if I want to give a pipe network, if I want to give a water supply network to any house, if I want to draw a plan, if I want to see how much area is there, which facilities are near to that site or construction what I am building, in every aspect you can use this technology. And this is why it is accurate, because we have divided whole latitudes and longitudes, and we have a earth tree, and then we are giving it the coordinate system, so it is never wrong, because we are applying all maths towards that. Mathematical modeling, mathematical formulas are given towards it. So this is how this technology works on, and we provide the various coordinate systems also. We are also going to see that in detail what is coordinate system, why coordinate system is important. As I said that on the earth surface we have degree, minute and second, right? How much earth has traveled, how much earth is rotating, that is degree, minute and second. But if I want it into the ratio of feet, inch, yard, area, that is what data we have captured, vector data features. Remember the point, line and polygon. The area, if I want to measure, how can I measure? On this earth, I cannot measure the area. On this earth's grid, what I have shown, I cannot measure the area accurately. So what I have to do? From the globe, I have to convert to the flat. And that is why I have to provide the coordinate systems. And there are numbers of coordinate systems and the projections and all. We are going to see that also in detail with reference to this, that what is the shape of earth, how this latitude, longitude, how we have collected the data, and that is what is the accuracy of data. So this is the accuracy of data. I guess you are clear with the shape of earth, the concept of universe and space, and you are clear why we are making vector and raster data. Thank you.